I haven't seen anyone show the math/chemistry way to solve the potato paradox, so I'm going to show that here. Other videos explain it with just logic, but I'm going to take it a step further, or actually several steps further. This video is going to be much longer than other people's videos that explain this, but while they make short videos using clear logic, this video is intended to be an actual proof. Because sometimes you can be led astray by logic, especially with something that like this when it's actually called a paradox, which means you're going to get the opposite results of what you would expect just using logic. So I have 4 separate proofs on how to solve this problem and the proofs that you will actually be correct. And these are the methods that you would use if you're working in a chemistry lab, diluting or concentrating chemicals. Okay, so the paradox: 100 kilograms of potatoes, 100 pounds, whatever, goes from 99% water to 98% water after you let them set overnight or for some time. So what's the new weight? It starts at 100 kilograms. You lose 1% of water, it looks like. So how much will the new weight be? So first step I'm going to do to solve this problem is I'm going to use a chemistry version to solve this, just because that way you can use this same type of example to solve chemistry problems. All you do is just change kilograms of potatoes to milligrams of salt or sodium chloride. The reason I'm changing it from potato is because potatoes are like 80% water. They can't go up to 99% water. I just Googled the water percentage of potatoes. And also I'm going to change the total mass, which is in kilograms right there. I'm just going to change that to milliliters of solution. So instead of kilograms of potatoes per kilograms of total mass, I'm going to change this to milligrams of salt per milliliters of solution. And this nice chemistry version here will work for anyone that takes a chemistry class. And then when you get your answer in milligrams or milliliters, you simply just change that back to either kilograms or total mass. And that's the total mass right there. Okay, so first step is just the logic of it. If you want to minimize your math, I've seen this is how I've seen it explained in other videos. What this means is when you go from 99% water to 98% water, what that actually means is you're going from 1% potato to 2% potato. So it's 2 times the concentration. It's like a cleaning solution. You're at the store and you can buy a cleaning solution that's 1% cleaning solution or 2%. Which one do you want to get? This is why I changed it from kilograms of potato per kilograms of total mass to milligrams per milliliter. So it looks like this in a chemistry version. 1 milligram of say salt, sodium chloride, per 100 milliliters. That's the same thing as 1%. Goes to 2%, so that's 2 milligrams per 100 milliliters. This fraction will simply reduce from 2 per 100 to 1 per 50. So it's 1 milligram per 50 mils. You went from 100 mils to 50 mils, and we just substituted kilograms to mils, so that means you went from 100 kilograms to 50 kilograms. You have half the volume, which also means 1/2 the weight, or 1/2 of the total mass. That's the first version. Version number 2, kind of similar. What I'm doing is just going to go from 1% sodium chloride solution to 2% sodium chloride solution, or salt water basically. 1% means the same thing as 1 milligram per 100 mils. 2% means 2 milligrams per 100 mils. But we cannot magically double the amount of solution we have. We can't go from 1 milligrams of salt to 2 milligrams of salt, because that just means we magically pulled a milligram of salt out of the air. So you can only decrease your water. You cannot increase your salt or the dry potato factor. And we decrease the water through evaporation by letting the potatoes set, or if we have a saltwater solution, we let it set and let it evaporate, or we can put it on a hot plate and boil it off. So we end up with 2 milligrams per 100 mils. That's our 2% solution right there, but we're not allowed to have 2 milligrams because we're only given 1 milligram of salt to begin with. 2 mgs per 100 mils equals 1 milligram per a certain number of mils. We don't know what that is, so just set up your equal, solve for this volume right here. Go through the algebra to solve for V. As a little side quest here, I'm going to show why cross multiplication works or prove that method. First off, we got our variable in the denominator. We don't want that, so you have to multiply both sides by V. When you multiply this by V, it just cancels out and becomes 1. So what you're really doing is multiplying this side by V. So you multiply this by V, and you want to get that out of the denominator, so you have to multiply both sides by 100. Then that'll disappear, so you're really just multiplying that by 100. So when you cross multiply, it's just a quick way of getting rid of your denominators. Anyways, go through the algebra, you end up with 50 mils, which if you turn that back into total weight, it's 50 kilograms. So you cut your weight in half. I've showed all the units here, but I'm not going to go through the detail. What this means is when you do 2 mgs times volume ml, it'll look like this. Keep track of your units and what happens to them, and when you divide, your milligrams should cancel and you're left with the units that you want, which is mils. So this is a good way to make sure that you're on the right track and your math is set up correctly. Next up, I'll use the equation that's taught in first year in organic chemistry in college. For chem majors and minors, you take inorganic 1 and 2 and then organic 1 and 2. So anyways, this is kind of what we learned at the beginning. Volume times concentration equals volume times concentration. Volumes in mils, concentrations in mgs per mil. I wrote kind of small there. I keep forgetting and doing that. The mils cancel. You're left with mgs, so you're left with milligrams equals milligrams. So just plug in our numbers. We're given 100 kilograms of potatoes. Remember, I changed kilograms to mils. And then our concentration is 1%, so it's 1 mg per 100 mils equals our new concentration over here. We have some volume with a 2% solution, 2 mgs per 100 mils. Go ahead and solve for your V algebraically. Keep track of your units. 100 mils divided by 100 mils equals just 1 milligram. Bring that down right here. Then this is 2 mgs per 100 mils. On second thought, I should have reduced that to 1 per 50 to make it easier, but oh well. And then, so we take this, divide it by this. So we're actually multiplying by 100 over 2. 100 mils over 2 mgs. Notice I left that 1 there, so the mgs will cancel. And the volume will equal 100 divided by 2, which is 50. Or 50 milliliters. All the units did what I wanted them to do. So for the most part, looks correct. Next up, sloppy handwriting here. This is the algebraic version I came up with, just trying to use logic, but I like this version here. You got a 1% solution, 1 mg per 100 mils, or 1 kilogram of potato per 100 kilograms, sorry, 1 kilogram of dry potato versus 100 kilograms of total mass or total weight. But anyways, I've changed everything to mgs and mils. So we have to subtract a certain volume. Let's go back to the salt water version. 1 milligram salt, sodium chloride, NaCl, right there, per 100 mils. We got to stick this on a hot plate and boil off a certain volume to get 2 gram, sorry, that's supposed to be, yeah, that's milligrams. 2 milligrams per 100 mils. So we go from 1% to 2%. Just solve for V, and again, make sure all your units do what they're supposed to. 1 mg times 100 mils equals just 100 mg mils, because that 1 kind of disappears. 100 mg mils, bring your 2 down to here. 2 times this whole thing, looks like that. Carry your units all the way through, so we end up with 2 mgs times volume mils. Again, just follow the units, make sure they're doing what you want them to do. Go ahead and solve for V down at the bottom, and you're left with 50 mils, which is half of the weight.